So let's now begin with the first question. And this question says, what is the difference between SDLC and STLC? So here we have SDLC, which is the software development lifecycle. Software development lifecycle is the steps that we go through in order to develop our software. On the other hand, the software testing lifecycle are the steps that we go through in order to test our software. So both of them is a life cycle, but the difference is the software development life cycle is talking about developing the software, but the software testing life cycle talks about testing the software. So like we see here, software development life cycle is a process. Okay, both of them is a process used by the software industry to design, develop, and test high quality softwares. The software development lifecycle aims to produce a high quality software that meets or exceeds customer expectations, reaches completion within times and cost estimates. Of course, we have two types of software development life cycles. We have sequential life cycles like the waterfall and V model, and we have iterative and incremental life cycles like Agile, Scrum, Kanban, RUP, and Lean programming, for example. On the other hand, when we talk about the software testing life cycle, it means that mostly we are talking about the test process. So the software testing life cycle is a sequence of activities performed by the testing team to ensure the quality of the software of the product. The software testing lifecycle is an integral part of software development lifecycle, but software testing lifecycle deals only with the testing phases. So in software testing lifecycle, we begin by planning the testing plan, for example, then designing our test cases, then executing them, then reporting the status of our project to the stakeholders. Also, some people say in the V model, the left side of the V model is the software development lifecycle, because in it we begin to analyze the requirements, gather the requirements, design the software and build it. Then on the right hand, we have the test levels on which we begin to plan, design, and execute our test cases. So this is the software testing lifecycle, the right hand side of the V model. So like we see here, this is the software development lifecycle. We gather the requirements, analyze them, design the software, write our code, test our code, then deploy the software. The testing step of the software development lifecycle is the software testing lifecycle. So if we zoom in on testing here, we find requirements analysis, test planning, design, environment setup or test implementation, execution, and then test closure activity. This is a very important question that is asked a lot in interviews. Then we have what are the different levels of software testing. So in software testing, we have four main levels. We have unit testing, integration testing, system testing, and acceptance testing. Sometimes we call unit testing component testing or program testing or module testing. So at the beginning, we have unit testing, and unit testing aims to verify each part of the software on its own by isolating it and then perform tests to demonstrate that each individual component is correct in terms of fulfilling requirements and the desired functionality. So for example, I have my code. This code is composed of classes of code. Each class of them can be considered as a unit, okay? The unit is anything that can be tested separately. Who does unit testing? Most of the time it is done by developers. We have some exceptions in some agile projects, but most of the time the developer is the person who performs unit testing. Then we have our units. We begin to perform integration testing between those units or components. So here we test the different parts of the system in combination in order to assess if they work correctly together. So we have two components, we test the interface and the connection between those two components. By testing the units in groups, any faults in the way they interact together can be identified. Mostly also, component integration testing is done by developers. Then we have the testing level that the tester is responsible of, which is system testing. Here we tested the components, then we tested the integrations between them. Now we have a whole system, we can test this whole system. Who tests it? The testing team or the tester, okay? So this is system testing. All the components of the software are tested as a whole in order to ensure that the overall product meets the requirements specified. Then at last we have acceptance testing. Acceptance testing is like system testing, but it is not done by testers. It is done by stakeholders, by, for example, users, okay? And also, the goal of acceptance testing is not to find many defects, but the goal is to make sure that our software is ready to be deployed to the customer. So acceptance testing is the level in the software testing process where a product is given the green light or not. Is it ready to be delivered or not? The aim is to evaluate whether the system complies with the end user requirements and if it is ready for deployment. And mostly the end users and the stakeholders are the one who perform acceptance testing. Also, we have types of acceptance testing like alpha testing, beta testing, contract and regulatory acceptance testing, and also operational acceptance testing and user acceptance testing. We have UAT and OAT, user acceptance testing and operational acceptance testing. But here comes a tricky question. The person might ask you, what is the difference between component integration testing, which is this, and system integration testing? And when do we perform system integration testing? Okay, so we know now component integration testing. This is integration testing. We integrate the components together and test them. Then we have system testing. So what if we have two systems, for example, a front end and a back end, or a website and a mobile application who interact with each other? In this case, we will have system integration testing between those two systems, okay? So for example, you wrote a post from the Facebook application on your Android phone. Your friend is reading this post from, for example, a browser on his laptop, okay? And he is interacting with like or love. So here we need to test the interaction between those two systems, the mobile application and the website. Component integration testing is, like we said, the responsibility of the developers, but system integration testing is mostly the responsibility of the testers, and it comes after system testing. The third question says, explain the steps that the defect goes through from discovery to resolution. So you found a defect, you reported this defect to your developer in your team. So what are the steps that this defect goes through? So the first thing is that you as a tester, you find a defect. So its status is new, mostly, okay? In many tools, it's called new, it's called to do anything in agile projects, for example. Then the development project manager will analyze the defect. It depends on the process, okay? The developer himself might analyze the defect, the team leader or the technical lead might analyze the defect. So is this a valid defect? If it is not a valid defect, we say that it is rejected. If it's a valid defect, then we ask another question, is it in scope? If this defect is in scope, so we say, is it already raised? In this case, yes, it is duplicate. But if it is not already raised, then this is a defect. But if it is not in scope, what does not in scope means? So for example, we have an iteration in our agile project. Inside this iteration, we are working on the login and registration functionalities. But you as a tester found a defect in another functionality. So this defect is not in the scope of this iteration or this sprint, okay? In this case, this defect is deferred to another iteration or another sprint. Is this defect already raised? If it is not already raised, the developer starts fixing the defect and then the status is in progress. If he has fixed it, he can say that it's fixed or it is pending retest. Then you begin to retest the code. If the test passes, then it's closed. If the defect did not pass the testing, in this case, it is reopened and then the developer starts fixing it again. So this is called the defect lifecycle. This is another illustration here, but it is the same. We have new, then assigned, then open, fixed, retested, and closed. When I assign it to the developer, he might reject it. Why would he reject it? Because it is deferred or duplicate. And also, when the defect is fixed, we can say after retesting that it is not fixed, and then we begin to reopen the defect. But in my opinion, the illustration on the left has something wrong. So here, in retesting, this arrow should come, not from here. Why? Because when you perform as a tester retesting, you decide, is this defect closed or reopened? So the developer is not the person who decides, does this defect require reopening or not? No, it is the tester. After performing retesting, he begins to reopen the defect if it is not fixed.